our next word problem. So we have two professional hamster divers that dove into a pool of water from an initial height of 5 feet. Their paths are modeled by the following functions where x is in seconds and f of x and g of x are vertical feet. The x-axis represents the water level. So real quick about this last statement. So we have our coordinate plane, and all it's saying is that this x-axis is where the water is. Right, so these two hamsters are going to dive in from an initial height of 5 feet. So they're going to be 5 feet up, and then they're going to jump in, and they're going to have their parabolas there, right? So we'll have to look at the x-intercepts here. Okay, so our two functions, f of x equals 2x plus 5 minus 8x plus 5, and g of x, we have x squared minus 7x plus 5. So let's go down and look at the questions. Which hamster entered the water first? Support your conclusion mathematically. And then, which hamster emerged from the water last? Support your conclusion mathematically. So we've got to show our work. And which hamster was underwater the longest? Support your conclusion mathematically. Okay. So essentially what we need to find for these two functions is their x-intercepts, right? Because we know they're both going to jump from an initial height of 5 feet. They're going to hit the water, and then they're going to come out a little bit later. But we want to know which one hit the water first and which one comes out of the water later. So it comes back up to that x-intercept, right? So if we look at it, here's our graph. Again, they're jumping from the 5 feet. That first x-intercept is where they enter the water. And that second x-intercept is where they emerge out of the water, right? So they enter, they come back out. Okay, let's see if I can... Okay, so which hamster entered the water first? We're going to need to find the x-intercepts. So remember that there's two ways to find the x-intercepts. We can factor, and if factoring isn't possible, you have to use the quadratic formula. So for the first one, for f of x, okay, and I got to do all the work here. So for f of x, we have two x squared minus 8x plus 5. Okay, so I'm going to try factoring this one first. So looking for a common factor between 2, negative 8, and 5, well, there isn't any. 5 is a prime number, so there's not a common factor between these three. So we have to go straight to doing our multiplying. Okay, so we do 2 times 5. So we'll have x squared minus 8x plus 10, right? Because we have 2 times 5 there. And now we got to do our x. What multiplies up to 10 and adds to negative 8? What multiplies up to 10 and adds to negative 8? Well, 1 times 10 is 10, but none of those combinations will give us a negative 8. 3, 4, 5 times 2 is 10, but again, none of those combinations will give us a negative 8. So we cannot factor this quadratic. So we're forced to use the quadratic formula, right? Because no two numbers multiply up to 10 and add to negative 8. So I'm going to erase this here. We know that that can't work. And we're going to use the quadratic formula. So we have a equals 2, b equals negative 8, and c equals 5. And we're going to go ahead and plug it into our quadratic formula. And again, guys, you should have this written down on your note card what the quadratic formula is. So I'm just going to plug it straight into the formula. So we have negative times negative b plus or minus square root b squared minus 4 times a times c, all divided by 2a. Okay. Now simplifying this out. Negative times negative 8 is 8, plus or minus square root. Negative 8 squared is 64. Negative 4 times 2 is negative 8. Negative 8 times 5 is negative 40, so that's a minus 40. Divided by, 2 times 2, which is 4. And again, simplifying this out, that gives me 8 plus or minus square root of 24 divided by 4. So now looking at the square root of 24, 24 can be simplified down. It's not a perfect square, but we can simplify that. So I'm going to do this on the side here. So 24 can get broken down into 2 times 12. 12 can be broken down into 12 times 6, and then 6 can be broken down, but we're not left with any pairs there, right? So we want to take out pairs. So that 24 gets broken down to 2 times 2 times 2 times 3, and 2 times 2 times 2 times 3. And we're going to take out pairs. So this simplifies out to 8 plus or minus, we're taking out a pair of 2's, so just 1, 2. Square root what's left inside, 2 times 3, which is 6, all divided by 4. And we look to see again if we can simplify this. So if these three numbers can be reduced, we go ahead and we reduce this, which they can be reduced. We can divide them all by 2. So it's 4 plus or minus root 6 divided by 4. Ooh, that's not looking good. Okay, 4 plus or minus root 6 divided by 2. Alright, so we could have divided all those by 2. 8 divided by 2 is 4, 2 divided by 2 is 1, 4 divided by 2 is 2. Okay. So now we can go ahead and plug these into our calculator. We have 4 plus root 6 divided by 2, and we have 4 minus root 6. And remember that this needs to go in parentheses when you put it in your calculator. Okay. So for the first one, if you do 4 plus square root of 6 divided by 2, that'll give us 3.225. And remember, you want to round to 3 decimal places because you want to get these numbers as close as possible. And then we'll have 4 minus square root 6 divided by 2, which gives us 0.775. And again, rounded to 3 decimal places. Okay, so again, all that was for f of x. So we found the two x-intercepts for f of x. Okay, and we'll graph those a little bit later. So now we're going to go ahead and find the x-intercepts for g of x. So I'm going to do the Okay, I'm going to do the work for g of x down here because I have no room. And we'll go back to answering these questions, right? So for now, remember that we're just finding the x-intercepts. So g of x equals x squared minus 7x plus 5. Okay, so first thing we want to do is check if we could factor this out. So there's no common term. A is 1. There's no common term between these. So we can go straight to doing our x. So what multiplies up to 5 and adds to negative 7. And again, we can do our x because a equals 1. Okay. Okay, so let's see, 5 multiples of 5 is just 1 and 5. That doesn't give us a negative 7. We have, that's it. That's the only one. So we cannot factor here. We can't use the x method. Okay, so we have to use the quadratic formula again. Right? Quadratic formula always gives you the x-intercepts. Okay. So we make our little list. A is 1, B is negative 7, C is 5. And we go ahead and plug in. We have negative 7, right? B is negative 7, plus or minus negative 7 squared minus 4 times A times C. And again, I'm plugging all these values in. Times 2 and, oops, A is 1. Okay, now simplifying this out, that gives me a positive 7 plus or minus negative 7 squared is 49. Negative 4 times 1 is a negative 4. Times 5 is a negative 20, so that's minus 20 divided by 2. And again, simplifying one more time, we have, I'm actually going to move this up here, 7 plus or minus the square root, 49 minus 20 is 29, divided by 2. Okay, so now our focus comes on to our radical. Square root of 29. Can 29 be broken down? No, it's a prime number. So that is already factored. That's already simplified as far as it can go. So we have 7 plus root 29 divided by 2. And we have 7 minus root 29 divided by 2. So grabbing our calculators. And remember that you want to put these in parentheses. Right? Some calculators require the radical be in parentheses. So we have 7 plus square root of 29 radical divided by 2 equals 6.193. And again, you want to round it to 3 decimal places at least. 6.193. And then we're going to do the same exact thing and this time subtract. So we have parentheses 7 minus square root 29 parenthesis, we'll close, divided by 2 equals 0.807. Okay. And here we have our 2 x-intercepts for g of x, for that second hamster that dove down. Okay, so now that we have our x-intercept for both f of x and g of x, we can make a generic graph. So I'm gonna try. Okay, so I know I'm gonna need positive values. That's not straight. Bear with me. Don't know why I made it so big. Okay, so I don't like that. I'm going to redo it. There you go. That's much better. Okay, so applying the x-intercepts. So we know that each hamster started with an initial height of 5 feet, right? Going back to that problem, it stated that. So our y-intercepts for each one of these are 5. So I'm going to say that's 1, 2, 3, 4, 5. Okay, I just moved the x-axis up. So again, 1, 2, 3, 4, 5. So we know that both of these hamsters jumped from an initial height of 5 feet. So they both jumped from up here. So I'm going to say this is 1, 2, 3, 4, 5, 6, 8. Okay. So now going back, I know this is taking a little long, but f of x, we had our two, and I'm going to do f of x in blue. We had our two y-intercepts at 0.775 and 3.225. Okay, so we got to plot both of those in. And again, this is just a visual. So 0.775, that's 0.5. 0.775, I'm going to say is about right here. All right, so that is at 0.775. And then our other y-intercept was at 3.225. Right, so that's 1, 2, 3. And then 0.225 is about right there. Right? 3.225. And that was our f of x hamster here. So he jumped something like this. And he emerged somewhere out there. And if you want to get it accurate, you can find the vertex and plot the vertex. But again, we're only concerned with the x-intercepts. So that's what our first hamster's dive looks like. Now let's do our second hamsters. And I'm going to do this one in purple. All right, because I wrote g of x in purple. So g of x, these two here are our y-intercepts. So we have 0.807 is where he entered the water, right? Because that's going to be our left x-intercept. So 0.807, and again, these numbers are small, so it's going to be about there. We know 0.807 is bigger than 0.775. 0.807, and our other x-intercept was at 6.193, so 1, 2, 3, 4, 5, 6, 6.193. Okay, and again, this hamster also jumped from 5 feet. So looking at this one, our parabola should look something like that. I messed up horribly over there on the left-hand side right here, but that's fine. Okay, now going back to answering those questions. Okay, and I know all the work is here. You should be doing yours on a separate sheet of paper. So going to this first question, I'm actually going to erase all this work. You guys should have it written down. Okay, so which hamster entered the water first? Support your conclusion mathematically. So which hamster entered the water first? So again, blue is f of x, and purple is g of x. Okay, so looking at which hamster entered the water first, we've got to look at the left-hand x-intercepts. So the first one to enter was the 0.775. He entered, so f of x entered the water 0.775 seconds after he jumped, and g of x entered the water at 0.807. Right, so the one that entered faster is the lower x-intercept. It's f of x, 0.775. So which hamster? It was hamster f of x. And supporting our conclusion mathematically, and again, that's showing all your work, right? Whether it be the graph or it be the X-intercepts that you found using the quadratic formulas. And that's how you would support your conclusion. Which hamster emerged from the water last? Okay, so we know that they both jumped from 5. They hit the water in less than a second. And then which one emerged from the water last? So which one lasted the longest underwater? Well, f of x came back up. It emerged after 3.225 seconds, and g of x emerged after 6.139 seconds. So the one to emerge later was g of x, right? He emerged after 6.193 seconds being underwater. So g of x. And again, you support your conclusion by showing your x-intercepts for that right side. And which hamster was underwater the longest? Support your conclusion mathematically. Well, the one that was under the water the longest, it's going to be the one that came out of the water later on, right? Because if we look here, if this hamster f of x entered at 7.75, he stayed underwater till about 3.225. Right, so he was underwater 3.225 minus 0.775. He was underwater for a total of 2.45 seconds. Hamster g of x came out at 6.193. And he entered the water at 0.807, so he was underwater for a total of 5.386 seconds. So again, g of x, I mean, you kind of can tell straight from the graph that he was underwater for the longest time. G of x. So in supporting your conclusion mathematically, it's just that work right here. Okay, and I believe that's it for the study guide. Okay, so you guys have two 30-minute videos. I hope you guys do invest the time into watching these and taking notes and putting a lot of these down on your note card. And I wish you the best of luck on your Unit 5 exam.